aspiring mathematicians. Today I am going to show you how to multiply rational expressions. Now, what is rational expressions? A rational expression is an expression that can be written as a quotient of two polynomials, whereby you will have a polynomial in the numerator and you will have one in the denominator. And sometimes that polynomial might be a monomial, or it may be a binomial, or sometimes it may be a trinomial. But if it is a trinomial, you have to first factor out that trinomial to two sets of binomials. Now I'm going to get right into today's lesson and show you how to multiply rational expressions. I'm going to take you down memory lane. Remember when you were in elementary school or primary school and you were given two fractions to multiply? But guess what? Each of those fractions is what we call a rational number. And if the teacher gave you 2/3 and tell you to multiply it by a quarter, that is what it would look like. This part, or this first part here, that is a rational number of itself. And this other part over here is also a rational number. So you were taught from younger how to multiply two rational numbers. And we know off the top, we could have either reduced this and then multiply it out, and I'm going to show you because I like to take you down memory lane. Alright, let's go down memory lane. You can reduce this first, right, and this would give you now 1 times 1 over 3 times 2, and that would be 1 over 6. That would be your answer. Now if you did not reduce it, say for instance, alright, and I'm going to show you what will happen if you forgot to reduce where possible, then you will notice this is going to be 2 and this is going to be 12, and then when you reduce this you will end up with simply same answer as 1 over 6. Now that's all good. That was the teacher laying the foundation for you so that when you get to high school or to college, you will be versed on rational expressions. The difference between the rational number and a rational expression is simply that with the rational expressions, you will have variables and you will have more than just one term, which we call a monomial constant here, or the monomial. We could have a trinomial, but if we are given a trinomial, you have to first factor out the trinomial into two sets of binomials, and then you can go ahead and do what you have to do. So let's get right into rational expressions. So a rational expression, as I told you before, it could be written as you have a number in the numerator and a number in the denominator with an expression. You can have 3x over 4y, or you could have 3 over 6m. It doesn't matter. It could even be something with 1 over 2x. That is an example of a rational expression. Now, if we are going to multiply a rational expression now, we need to know how to go about doing this. By simple steps, we have to do cancellation, and we also have to think in terms of the factors. So we have to factor out certain things, take out the GCF, which we call it the greatest common factor, in order to simplify our expression. So with that being said, let's get into a simple example first, and then we can take it to another level. So our first example here would be x plus 1 over 4x times 8x over x squared. Now I must say to you that I'm using a big dot here. I'm not going to use the multiplication symbol because I'm dealing with variables here, which is x, and I want to keep it simple. I don't want you to think that, oh, I'm thinking of the variable. No, so that's the reason why I'm using a dot here, to show that it means that I'm multiplying. So let's get into this. Off the top, right, we can simplify this. And when we simplify this, we have a 4x here and an 8x here. So if we cancel out the x with the x, we have the 1 there. Then we cancel out the 4 here. Into 4 is 1 and 4 into 8 is 2. We cannot do anything with this x squared here into the x plus 1. Those are not like terms, because 1 is raised to the exponent 2, and here you have the x being added onto the 1, or 1 being added onto the x, meaning you have a binomial here and you have a monomial right here. So you cannot simplify that. Please don't make that mistake. So your final answer now is going to be, we are going to multiply across, because now we have, I like to rewrite it, what we have here, times 2, and we can put parentheses here if you want to, over 1 over x squared. Now the next step, we are going to multiply across here, so we have 2 parentheses x plus 1. It's always good to bring the 2 in front of the parentheses here and not at the end. It's just standard form of writing it. And we multiply across here, right, and we end up with x squared, and that is your final answer. And I always tell my students, put a cloud or box your answer. Now, this is very simple, all right? I like to give more than one examples. As you should know by now, variety is the spice of life, and I always like to start off first where it's something simple, then we build, 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 and get to something that is bigger, that we need to really know how to attack those type of problems. My next problem is going to be 9y squared minus 16 over 4y squared times 8y over 3y minus 4. You will notice that you have binomials going on here and monomials. But I should hope by now that you have identified that this is a difference of perfect squares. So if you don't know how to factor out difference of perfect squares, you can go back and watch my video on how to factor difference of perfect squares. So you have your 9y to the second power minus 16. This is a perfect square on this side, and this 16 is a perfect square. We should get 2 sets of binomials. One is going to have a plus in the middle, one is going to have a minus, and we will end up with 3y minus 4, and the other one is 3y plus 4. We put that over our 4y to the second power, and we have our multiplication sign here, or you can change it now because you're not dealing with the variable x, so that is fine. 8y over 3y minus 4. So looking at this, you have to look and figure out what can you factor out here. And if you notice, you will have 3y minus 4 here, and it is also down here. You can cancel that out, give you 1. This cancel out, give you 1. Please make sure that you're putting the 1 there and not leaving it blank and saying, oh, it canceled out and that's nothing left. That is not true. Trust me. 3y minus 4 goes into 3y minus 4 one time, and same thing for here. Okay? So now we have 4y to the second power and 8y. Guess what? We can reduce this. 4, because we have y and a y square, we already know that y squared is simply y times y. Yep. Y to the second power is y times y. So if I cancel out one of my y here, I'm going to be left with the y, and this is going to be 1. If I cancel my 4, I have 1 here. 4 into 4 is 1. 4 into 8 is going to be 2. Now I can rewrite what is left. So what is left, I have my 1 times the 3y plus 4, which is simply going to be, let's write this here. So for those students who need to see where I'm coming from, all right, I'm going to do this, okay? So you can see. For those students who are stronger in math, they can just jump right to the chase and see what everything is. Okay? This will be a 1 in front of it times that. So 1 times anything is going to be that thing. That thing, that thing. Yep, Lauren Hill said it. I can't sing to save my life, but I know tunes. Alright? Yes. Miss Wynn just know tunes. So 1 times this binomial is going to be that binomial, or that thing. So you have 3y plus 4, right? Multiply by 2, and you have, this is going to be over y, and you can put it over 1 there. So my answer now, when I'm going to multiply this, I can have 2 open parentheses 3y plus 4, because it's multiplied by 2 over y. You can't do anything else with this. Don't tell me, oh, but miss, I have a y here and I have a 3y. No, you can't cancel it out, because guess what? This is a monomial. This is a binomial, meaning that something is added onto the 3y. Yes. So because something is added onto it and nothing is added onto this y at the bottom, you cannot cancel anything out. Please, no, don't make that mistake. It's just simply saying that, oh, if you have apples and oranges, you cannot take away an apple alone from the apples and oranges. Meaning that if they're engrafted. No, you can't. So please don't make that mistake. This is your final answer. And I always tell my students, oh, box your answer or leave it in a cloud. I like to be fancy. Yeah, fancy, huh? Hair done, nails done, everything done. Yes, I like to do that. So, you should know me by now. I'm not going to stop here. No. I'm going to take it further, because I need to show you other little concepts that can help you to master this topic. And I want you to do well. So why not give it to you? Give it to me. Give it to me. In my next example, I'm going to show you a little trick when you're dealing with rational expressions, whether you're multiplying them or dividing them. Once you have rational expressions, you need to know this little trick. So if I gave you x minus 2 over 3 minus x times x minus 3 over 2, you might say to yourself, these two look almost alike, but these are like maybe what they call it, the additive inverse. How am I going to get it to look the same or look like a match in order to cancel it out? Guess what? You will have to factor out from this 1 and negative 1. It means that you have to change it so that it's going to look like this. And in order to do that, you're going to take out that negative 1 and watch what I'm going to do. So I'm going to rewrite my x minus 2, and under here, because I have over here my x minus 3 over 2, I need to get this 3 minus x to look like this. Furthermore, not only that, we should be writing this in standard form. So we're going to take out a negative 1, right, to factor it out. And I'm going to switch it now, and I'm going to have my x minus 3 to make it look like this factor here so we can factor it out. And if you don't believe me, hey, let's test it. Alright? So originally it was 3 minus x. Now I have my negative 1 and x minus 3. If you use your distributive property, you will have negative x, and this will give you positive 3. But you can't leave it like this. All you have to do, 3 minus x, that's how it's written. Isn't that the same thing like what we had up here? So therefore that will tell you that this factoring out with the negative 1 is correct. And that's why we have it here. So you have to do that whenever you have two factors that they look close but they're not close, meaning they look almost like a match but they're not a match. right? We call them the factors or the additive inverses of each other. And when we say the additive inverses, because look, it's this part. So be very careful there, all right? So let's continue now. So I have my factors here. I can cancel this out and cancel that out. Put your 1 there, put your 1. Don't forget to do that. So now you're left with x minus 2 times 1 over 2, and this is over negative 1, because negative 1 times 1 is negative 1. Now you can go ahead and multiply. Well, we know off the top that if we multiply these here, it's still going to be the same. X minus 2 over negative 1 times 2 is negative 2. And this is your final answer. Just like that. If you're given rational expressions that have quadratics in it, you have to factor out the quadratics and then go ahead and multiply them. So the next example that I'm going to give you has quadratic expressions in it, and you have to factor them out. So let's get right into it. And that example is x squared minus 11x plus 24 over x squared minus 18x plus 80, and we're going to multiply it, and I'm using a big dot here this time, x squared minus 9x plus 20 over x squared minus 15x plus 50. We have 4 quadratic expressions here to factor out. And if you don't remember how to factor out quadratic expressions, you can go back and watch my video on how to factor quadratic expressions, and that will help you build your confidence. So let's get to the first expression. So we are taking the last term, which is a 24, and we're finding the factors such that when added is going to give you the middle term, which is negative 11x. Now, the negative 11, you know, because you have a positive here, you have to have 2 negative factors there. And the first one, x and x, so we have 8 and 3. So these are both negative, and you can test it. Go back and look. The next one, you're taking the 80 here, finding the factors so that when added is going to give you negative 18. So we can do 8 and 10, and they are also both negative because the last term here is positive. Now the next part, now we're multiplying, and we are going to take the 20, and we will have 5 and 4. They're both going to be negative, and below we are going to take the 50, right? And we are going to use 10 and 5. Both are going to be negative, and you will end up with that. You must factor out your quadratic expressions so that you will end up with 2 sets of binomials. Once you do that and they're done correctly, then you're ready to look for any binomial that is the same. It must either be diagonal or vertical. It cannot be horizontal to cancel out. So please remember, must be diagonally or vertically, but not horizontally. So with that being said, I have here x minus 8 and x minus 8 can be cancelled out here. We put a 1 there. You must put your 1 because I don't want any of you students to tell me, oh, that is 0. Because once you cancel, nothing is left. No. And math is different because we are saying that this binomial into this binomial is 1 time, and this binomial in itself goes 1 time. All right? So next thing we notice over here, we can also cancel out the x minus 5 and the x minus 5 here. We cannot do anything with this x minus 10 and x minus 10. So please, I'm begging you, don't make that mistake. Please. All right? Don't make that mistake. So with that being said now, if I do 1 times x minus 3, I'm going to be left with x minus 3 as the first one there. And we're going to multiply it with x minus 4 right here. And we're going to put this over x minus 10, right? X minus 10. And that would be your answer. But if you want to get fancy and give it to me as a quadratic expression, right, you're going to use the FOIL method, and you know that this is x to the second power. You will have negative 3x and negative 4x, so it's negative 7x, and this is going to be plus 12 because 3 times 4 is 12 and it's positive, over x squared minus 20x plus 100. So you can, so your choice. You can either leave your answer like this, right, because nothing can be cancelled out here. And please don't try and tell me and look at this and say, oh, maybe I can do 2 into this or 4 into this and 4 into the 100. No, do not do that. No. So if that is the case where you might be tempted to do this with the error and cancel the 12 out, the monomial constant, no. Or I'll say reduce it, don't do that. Then leave your expression like this, where you will see that you cannot, and you cannot say, oh, let me try take out my negative 4 with my negative 10 and say, oh, 2 into negative 4 is going to be negative 2, and then this is going to be negative 5. No, 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 no. It doesn't work like that. This is your answer, all right? So be very careful there. So, in conclusion, I hope that this video has helped you tremendously. And now that you know how to multiply rational expressions and also bring your prior knowledge from whether it's primary school or what you call elementary school into this topic, and you will be great at it and you will master this topic. Not only that, you also have to bring your prior knowledge of how to factor quadratic expressions. And sometimes you might be given a quadratic expression where a is greater than 1. Then you have to go back and watch my video on that to help boost your confidence. So with that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And if you like what you see, don't keep this knowledge to yourself. It is very vital. A lot of students out there have a phobia for math, and I want to help them get rid of that phobia. So send them these videos so they can help to get rid of that phobia and be a better person in solving any math problem. Don't forget to hit that like button and also leave me a comment. I like to read them so that I can know what you're thinking of, and maybe you can make a suggestion as what you'd like me to do for my next video. I'm here to serve you and to give you my utmost when it comes to any topic, whether it's fashion, finance, or math education. So with that being said, thank you for watching and see you soon on the next video to come. Bye now.